Hello everyone. In this video today we would be discussing about the fundamentals of computing, execution of a program and debugging and what is the use of a duck debugger. Now let us get into the fundamentals of computing. First, the basic question is what is computers and is it really helpful for us or not? So it's a machine that can carry out any computational tasks, and it is also proven that given a sufficient memory and time, it can carry out any computational tasks. So, but how does it process? So for that, we should look into the components which are present in a computer. Inside a computer, we can see there are various components like power supply, drive base, and expansion slots. And when it comes to the motherboard, it is the main printed circuit board in a computer. It is the computer's central communication backbone connectivity point through which all computer components and external peripherals are connected. Motherboards can be found in virtually all computers and especially desktops and laptops PCs. Here you can see like back panel connectors, CPU in CPU socket and connection cards in PCI and PCLE slots. And next, let us get into the functional units. There are 5 functional units. Those are input, memory, arithmetic logical unit, output, and the control unit. Input unit, where we can see there are keyboards or CDs. It is a device in any hardware device that ends data to a computer, allowing you to interact with the control unit. Data can be in the form of words, symbols, and numbers, etc. The main function of an input device is to direct commands and data into the computer. And when it comes to CPU, Central Processing Unit, after receiving data and commands from the user, a computer system has to process the instructions provided using central processing units. It has basically two. You can see arithmetic logical unit and the control unit. In the arithmetic logical unit, it is a major component of the central processing unit of a computer. It does all processes related to arithmetic and logical operations like addition, subtract, and multiplication. And when it comes to the control unit, it is the component of a CPU that directs the operation of the processor. It tells the computer's memory and remaining all the arithmetic input and output devices how to respond to the instruction that has been sent to the processor. And when it comes to the memory unit, it has two types, RAM and ROM. Like it has both primary memory and the secondary memory. In primary memory, you can find RAM and ROM. RAM means random access memory, which is a volatile memory, and when it comes to ROM, it is a read-only memory, which is a permanent type of memory which cannot be altered. So it is a non-volatile memory. And secondary memory, it is the external memory of the computer which is used to store large amounts of data, for example the hard disk. And when it comes to the output devices, it is a device used to send data from computer to another devices or user. Most computer data output that is meant for humans is in the form of audio or video. Thus, most output devices used by humans are in these categories. Example, monitor, printer, speakers, projectors, etc. And when it comes to the binary format, the computer can't understand the language which we type to it, which we give to it. So it has its own language which is written in only zeros and ones, which is known as the binary format. The computer understands only this binary format. For example, the decimal numbers are denoted in binary format. For example, 1 is denoted as 001 and 2 is denoted as 010 and 3 is denoted as 011 and so on. And you can see an example that number 4 is stored as, you can see the last 3 digits 100, etc. Similarly, you can take other decimal numbers and convert it into the binary format. And when it comes to the execution in a computer, To begin with, all the data and commands related to the computational is stored in the memory. Commands are then brought into the CPU through the bus one at a time. Each command is executed inside the CPU. If the command requires any data, then again the CPU takes the required information from the memory and it gets executed using the data. Then the command will be stored inside the CPU. A program is a collection of commands. Now, let us see a small program. How does it run? In the four of the numbers that you are able to see, you can see that the last three digits are being changed. See, the sentence read memory location 001 is represented in the computer language as given. The last three digits is represented as 001 and read memory location 010 is represented by the following number. And to add two numbers, and it is also saying that to store the data in the memory location 1, again it is represented as 001 in the last three digits of the given number. And when it comes to the execution, the you can see that the highlighted green number is brought to the CPU. Then whatever data is stored in the memory location of 001 is brought to the CPU. Then in the step 2, execution of the given number is being taking place in the control unit of the CPU. If it requires any data, it takes the data from the location 1 and you will be getting the output as 4 to gives a number 4 to the CPU. And in step 3, it has taken the second number, that is 010, that is brought to the CPU, and whatever data is stored in the memory location of 010 is also taken to the CPU from the memory. When the execution is taking place in the control unit, whatever the data is stored from the location 2 is taken and the output is given as 1 to the CPU, since 001 is represented as 1 in decimal format. Then again it takes the third number, which is actually adding of two numbers according to the assembly language. So it adds the two numbers and whatever and if it requires any data, it takes it from the memory location and then it executes in the control unit. And after adding the two numbers inside the CPU using ALU, then the fourth statement is taken to the CPU. Then the number is stored in ALU to memory location 001. Execution of 001 is taking place in the control unit and it stores data in ALU number 5, because 4 plus 1 is 5 and it is said that it should be stored in location 1. So the output will be stored in the location 1. Now let us get into the assembly language. What is the requirement for an assembly language? Basically, it is very difficult for us to understand the machine language, which is a binary language, but when it comes to the computers, they understand only machine language. So to make it more reliable, assembly language was introduced. In assembly language, operations memory locations are addressed by names. See, in this you can see that location 1 is represented with num1 and location 2 is represented with num2. And when you see in CPU, you can see both the numbers in the control unit are represented with R1 and R2. So we would be giving simple names to for the execution. In the first one, you can see 001. It has given that move num1 and contents of the memory location num1 to CPU and register as R1. You can see whatever the in num1 the location, whatever data is present, it moves to the control unit R1 location. Similarly, the remaining steps are also followed. Then what is an assembler? The main function of an assembler is to translate the binary language assembly language into machine level language. An assembler does this job. It maps the names to the corresponding binary values. It is also a program. And when it comes to the inputs and outputs, the previous example shows only how to add numbers already present in the memory. Then, how does one add numbers provided by the user through the keyboard? This is the job of another program called the operating system. It is the most important software that runs on a computer. It manages the computer's memory and process as well as all of its software and hardware. It also allows you to communicate with the computer without knowing how to speak the computer's language. What is the need for a better language? Because it's very difficult to write large programs in assembly language. Several languages were created during 1960 to 80 to simplify the task of the programmer. So, assembly and machine languages are also called as low-level programming languages, and COBOL, Fortran, Pascal are called as the high-level programming languages. Here you can see in C language how to add two numbers and what are the meaning of those. The curly braces denotes the beginning and the ending of the program, and you will be specifying int num1 and num2, which are the memory locations to which the CPA has to take. And here you can see num1 is equal to get underscore int, enter the number 1. Here it reads a number from the input and stores it in the specified memory location. Then num1 is equal to num1 plus num2. Here it adds two numbers and stores the result in the location num1. It corresponds to the whole machine language program earlier. So even to print the whatever output we are getting, it writes the number on the monitor, which also involves the operation of an operating system. Then it tells the OS that the program executed successfully. Then we will get the required output. Then what is a compiler? A C compiler translates a C program to machine language, and there are many C compilers. We will use one called Clang. So coming to debugging, it's actually used to find the errors in a program. So I have taken a C program. So after the C program, actually here you can see that debug console. In that you can go, and after you have done your run and debug, you would be getting a set of, if you have any errors, you would be getting those errors. Here I have clicked Shift plus Control plus Debug, like capital D, to run and debug the following program. So there you could be getting variables, locals. Actually, if we take a program, for example, sum of two numbers, for that we should give the value. So in the locals there would be some random numbers and we can change it. After once the running, you would be getting successfully the task was executed. After getting this information, it is you can be confirmed that you have no error in your program. If you have any errors, it will be mentioned in the following statements during the debugging. So this helps us to find the errors in the program, and we can make the corrections in it. Now let us get into the concept of Duck Debugger in CS50.dev. What is the use of this Duck Debugger? It provides the conceptual help with computer science concepts, and it also helps the students to write more efficient code. Left side of this window, you would be finding the duck symbol. If you click on it, then your CS50 Duck Debugger is opened. Here you can ask any question to it, then you would be getting a detailed information about what you expected. If you have any doubts or if you are getting any errors in your code, then you can approach this Duck Debugger and it will make your code more efficient, and it helps to make it easy. For example, let us type what is the use of scanf. Now you can see that it's giving a detailed information about the functioning of scanf in the C programming. Similarly, any queries, if you have any queries, then you can approach this duck debugger